Today we're diving into the fascinating world of decoders. Whether you're a tech enthusiast or just curious about how information is processed, understanding decoders is essential. Decoders are everywhere, from the devices we use daily to the systems powering modern communication. In this video, we'll break down what a decoder is, why it matters, and how it fits into the bigger picture of technology. Let's start by exploring the basic idea behind a decoder and set the stage for a deeper understanding in the scenes ahead. Decoder is a device or algorithm that converts coded or encrypted data back into its original form. Imagine you receive a secret message written in code. The decoder's job is to translate that code into something meaningful. In electronics and computing, decoders play a crucial role in interpreting signals, instructions, or data so that systems can understand and act on them. This process is vital for everything from digital communication to computer operation. You might not realize it, but decoders are part of your daily routine. When you watch TV, your set-top box decodes the broadcast signal so you can enjoy your favorite shows. Similarly, when you use your smartphone, decoders help process the data sent and received, ensuring smooth communication. Even QR code scanners use decoders to translate patterns into readable information. These examples show just how integrated decoders are in our modern lives. Communication systems rely heavily on decoders. When you send a message over the internet, it's often encoded for security or efficiency. On the receiving end, a decoder translates that message back into its original form. This ensures that the information you send is accurately received and understood. Without decoders, digital communication would be unreliable and prone to errors, making them a cornerstone of modern connectivity. Electronics, decoders are used to interpret binary signals. For example, in a computer, a decoder might convert binary input into a specific output, like lighting up a particular segment on a digital display. This process is essential for devices to function correctly, as it allows them to understand and respond to various instructions. Decoders help bridge the gap between raw data and meaningful actions in electronic systems. It's important to distinguish between decoders and encoders. While a decoder translates coded data into its original form, an encoder does the opposite. It converts information into a coded format for transmission or storage. Both are essential in digital systems, working together to ensure data is securely and efficiently communicated. Understanding the difference helps clarify the unique role each plays in technology. There are several types of decoders, each designed for specific tasks. Common examples include binary decoders, which convert binary input into a one-hot output, and address decoders used in memory circuits to select specific locations. Other types, like 7-segment decoders, are used in digital displays. Each type serves a unique purpose, tailored to the needs of different electronic systems. Binary decoders are among the most common types. They take a binary input and activate only one output line corresponding to that input. For example, a 2 to 4 binary decoder takes 2 input bits and activates one of 4 outputs. This is especially useful in digital circuits, where selecting a specific line or device is necessary. Binary decoders are fundamental building blocks in digital electronics. Address decoders are vital in computer memory systems. They help select specific memory locations by decoding binary addresses. When a computer needs to access a particular memory cell, the address decoder ensures the correct cell is activated. This process is crucial for efficient data storage and retrieval, making address decoders indispensable in modern computing. 7-segment decoders are commonly used in digital displays, such as clocks and calculators. They convert binary input into signals that light up specific segments of a display to form numbers. This allows users to easily read numerical information. 7-segment decoders are a practical example of how decoding technology makes information accessible and user-friendly. At their core, decoders use logic circuits to interpret input signals. These circuits analyze the input and determine which output should be activated. The design can range from simple to complex, depending on the application. By breaking down coded information into understandable outputs, decoders enable devices to perform specific tasks accurately and efficiently. Decoders are built using logic gates like AND, OR, and NOT. These gates process the input signals and produce the desired output. The arrangement of these gates determines how the decoder functions. Understanding the role of logic gates helps demystify how decoders operate at a fundamental level, making the technology more approachable. Decoders are essential in computing, where they help manage data flow and control operations. For example, in CPUs, decoders interpret instruction codes, enabling the processor to execute commands correctly. They also play a role in memory management, ensuring data is stored and retrieved efficiently. Without decoders, computers would struggle to function as we expect. In communication systems, decoders are used to interpret encoded messages. For example, in digital television, the signal is encoded for transmission and decoded at the receiver. This ensures that the information sent is accurately reconstructed for viewing. Decoders are also used in wireless communication, helping devices understand and process incoming data. Audio and video decoders are specialized types that convert compressed media files into playable formats. When you stream music or watch a movie online, decoders translate the encoded data into sound and images. This process allows for efficient storage and transmission of media while ensuring high-quality playback for users. Security systems often use decoders to interpret encrypted signals. For example, access control systems decode signals from keycards or biometric devices to grant or deny entry. This ensures that only authorized individuals can access secure areas, making decoders a key component in modern security solutions. Networking equipment uses decoders to interpret data packets sent across networks. Routers and switches rely on decoders to understand where data should be sent, ensuring efficient and accurate communication between devices. This process is fundamental to the operation of the internet and local networks alike. Wireless devices, such as smartphones and Wi-Fi routers, use decoders to process incoming signals. These decoders translate the encoded data into usable information, allowing devices to connect and communicate seamlessly. This technology is vital for the convenience and reliability of wireless communication. Storage devices like hard drives and SSDs use decoders to manage data retrieval. When you access a file, the decoder interprets the storage format and delivers the correct data. This ensures that information is stored and retrieved accurately, maintaining the integrity of your files. Robots use decoders to interpret control signals and execute precise movements. For example, a robotic arm may receive encoded instructions that are decoded to control its joints and actions. This allows robots to perform complex tasks with accuracy, making decoders essential in automation and robotics. Modern vehicles use decoders in various systems, from engine control units to infotainment. These decoders interpret signals from sensors and user inputs, enabling features like navigation, entertainment, and safety systems. As cars become more advanced, the role of decoders continues to grow. In industrial automation, decoders help control machinery and processes. They interpret encoded instructions from control systems, ensuring that machines operate correctly and efficiently. This technology is crucial for manufacturing, where precision and reliability are paramount. Medical devices often use decoders to interpret signals from sensors and transmitters. For example, heart monitors decode electrical signals from the body to display vital information. This enables healthcare professionals to make informed decisions and provide better patient care. Smart home devices like voice assistants and smart thermostats use decoders to process user commands and sensor data. This allows them to respond intelligently to your needs, making daily life more convenient and efficient. Decoders are at the heart of the smart home revolution. From gaming consoles to digital cameras, consumer electronics rely on decoders to function. These devices use decoders to process input signals, display images, and play audio. The seamless experience we enjoy with modern gadgets is made possible by advanced decoding technology. Banking systems use decoders to process encrypted transactions and ensure secure communication. When you use an ATM or make an online payment, decoders help verify your information and protect your data. This technology is vital for maintaining trust and security in financial services. Educational tools and platforms use decoders to process multimedia content and interactive features. For example, online learning platforms decode video lectures and interactive quizzes, making education more accessible and engaging for students worldwide. The entertainment industry relies on decoders for streaming services, gaming, and digital content delivery. Decoders ensure that high-quality audio and video are delivered to your devices, providing an immersive and enjoyable experience for users everywhere. Transportation systems use decoders to process signals from sensors and communication devices. For example, trains and airplanes rely on decoders to interpret navigation data and ensure safe operation. This technology helps keep people and goods moving safely and efficiently. E-commerce platforms use decoders to process payment information and manage secure transactions. When you shop online, decoders help verify your identity and ensure that your data is transmitted safely. This technology is essential for building trust in online shopping. Cloud computing services use decoders to manage data transmission and storage. When you upload or download files from the cloud, decoders ensure that your data is correctly interpreted and delivered. This enables seamless access to information from anywhere in the world. Artificial intelligence systems use decoders to interpret input data and generate meaningful outputs. For example, in natural language processing, decoders help translate text or speech into actionable information. This technology is driving innovation in AI and machine learning. Internet of Things, IoT devices use decoders to process data from sensors and communicate with other devices. This enables smart environments where devices can interact and respond to changing conditions, making homes, cities, and industries more efficient. Satellite communication systems use decoders to interpret signals sent from space. These decoders ensure that data transmitted over long distances is accurately received and processed, supporting everything from GPS navigation to global broadcasting. Broadcasting systems use decoders to convert transmitted signals into audio and video for viewers. Whether it's radio, television, or online streaming, decoders ensure that content is delivered in a format that's easy to enjoy, connecting audiences around the world. Gaming consoles and PCs use decoders to process graphics, audio, and input signals. This allows for smooth gameplay and immersive experiences. Decoders help ensure that games run efficiently and that players enjoy high-quality visuals and sound. Voice recognition systems use decoders to interpret spoken commands and convert them into digital instructions. This technology powers virtual assistants and smart devices, making it easier to interact with technology using natural language. Navigation systems, such as GPS devices, use decoders to process signals from satellites and provide accurate location information. This technology helps drivers, pilots, and sailors find their way safely and efficiently. Smart wearables like fitness trackers and smartwatches use decoders to process sensor data and provide real-time feedback. This enables users to monitor their health, track activities, and stay connected on the go. Environmental monitoring systems use decoders to interpret data from sensors measuring air quality, temperature, and other factors. This information helps scientists and policymakers make informed decisions to protect the environment. Researchers use decoders to process complex data from experiments and simulations. This technology enables scientists to analyze results, draw conclusions, and advance our understanding of the world. Space missions rely on decoders to interpret signals sent from spacecraft and satellites. This ensures that valuable data collected in space is accurately received and analyzed on Earth, supporting discoveries beyond our planet. Designing decoders comes with challenges such as handling errors, ensuring speed, and maintaining security. Engineers must balance these factors to create reliable and efficient decoders for various applications. Ongoing research continues to push the boundaries of what decoders can achieve. The future of decoders is bright, with advancements in artificial intelligence, quantum computing, and communication technologies. As our world becomes more connected, decoders will play an even greater role in enabling seamless interaction between people and machines. In summary, decoders are the unsung heroes of modern technology. They transform coded information into meaningful outputs, powering everything from communication systems to smart devices. By understanding how decoders work and where they're used, we gain a deeper appreciation for the technology that shapes our world. Thanks for joining us on this journey into the concept of decoders.